So today we're going to go over section 4.1, which is radian and degree measure. And so part of knowing what radian and degree measure is going to come from our unit circle. So if you have your unit circle picture, you're going to want to get it out because we're going to look at what radian actually means. Okay, so a circle all the way around is called 2 pi. And 2 pi is approximately equal to 6.28. Which tells us that we have a little over 6 radians in our circle. It's kind of like dividing your circle like a pie into 6 pieces, except we have 6.28 pieces. So this little part is our 0.28. Yeah, probably. Okay, and we always work from our circle in a counterclockwise motion. Okay, so we always start right here on our x-axis. And then we go counterclockwise and we stop at what's called our terminal side. Okay, so whatever our angle measure is, we stop at what's called our terminal side. Okay, and so we call that angle theta. Okay, so S is our arc length and R is our radius. Okay, and then we'll look at some common ones in just a minute. Okay, so I'll scroll down a little bit, like to there. Okay, and so then that part, then you can see the bottom circle. And on our bottom circle, we're looking at some common measurements that will help us. And these are also on your unit circle. But we know that pi over 6 is one of the common ones that's used, and that's just barely up from your x-axis. Because remember, we're going counterclockwise. And then pi over 4 divides it into 4. Pi over 3 divides your top half of your circle into thirds, so it's approximately even with your y-axis. Pi over 2 is up here because you're dividing the top half of your circle in half. So it's like dividing your circle into quarters. Pi goes all the way around to halfway, and 2 pi goes all the way around the circle together. Okay, I'm going to assume we're good. Alright, so if I look at example 1, it says to graph 13 pi over 6 and then find one positive and one negative coterminal angle. So I'm going to sketch my circle. Okay, and I know that 13 pi over 6 is the same thing as I know that all the way around my circle is 2 pi. So I'm going to take 2 pi away from that, so that I can, because this is an improper fraction. So if I reduce this, then I end up with 2 pi and 1 pi over 6. So then if I subtract 2 pi from it, then I get 1 pi over 6, which is the same thing as pi over 6. So that's actually what I'm going to graph. It's going to be pi over 6. And I know that pi over 6, if I start on my x-axis and I go counterclockwise, that pi over 6 is going to be approximately there. Okay, and that's on your unit circle. I reduced my fraction. 6 goes into 13 2 times with 1 left over. And then I took away the 2 pi, because I could go graph this, but I'd have to go all the way around my circle, 2 pi, and then up another 1 pi. So it's just easier for me just to reduce it and then just do the 1 pi part. Okay, and then it says to find one positive and one negative coterminal angle. And your positive is when you're going counterclockwise, and your negative is when you're going clockwise. So if I start in my x-axis and I go counterclockwise till I get to that angle, then I end up at pi over 6. So I know my positive coterminal angle is pi over 6. If I go negative in the negative or counterclockwise direction, then I know that this is going to be all of this 2 pi all the way around except for this part, right? I'm going to go all the way around my circle except I have to stop because I don't get that part. So then my negative angle is 2 pi minus pi over 6. So I'm going all the way backwards except for just this one triangle that I'm not allowed to go into. And then I know that 2 pi is the same thing as 12 pi over 6 if I get common denominators. And so then if I subtract 1 pi over 6 from that, then I know that my negative angle is going to be 11 pi over 6. Okay, so you go in your positive direction, or you go counterclockwise in your positive direction, and you get that angle. If we go clockwise, then we get this angle. Yes. Yes, you draw. Okay, we'll do another one. That's the distance all the way around your circle.
That's this one. Copy this down here.
Can you dumb this down? I thought that was dumbed down. One is showing that I'm going counterclockwise, and the other one showing that I'm going clockwise. They just help me keep straight which direction I'm going. No. To find our positive angle, we took this and we subtracted 2 pi. To find our negative angle, we took 2 pi and we subtracted that. That's basically the difference. I'm aware that there's a step there. I've done that all day. Okay, so let's do another one. So we're looking at 3 pi over 4. Okay, I know that pi over 4 is what divides our, this is like pi over 4, divides our top half into fourths. So 3 pi over 4 is just 3 of those pieces. So I know that 3 pi over 4 is over here. Okay, it's like 1, 2, 3 pieces of my puzzle. Okay, and that's also on your unit circle, so you'd be able to tell based on your unit circle. Okay, so to find my positive angle, I go in the positive direction. So if I go in the positive direction to get to that angle, I actually just end up with 3 pi over 4. So I know my first positive coterminal angle is just 3 pi over 4. To find my negative angle, I have to start on my x-axis, and I have to go backwards. And I know that the distance all the way around the circle is 2 pi, but I'm not doing anything with this section, so I'm taking 2 pi minus 3 pi over 4. Okay, and so this is like 2 pi over 1. So to get common denominators, I multiply everything by 4. So I end up with 8 pi over 4 minus 3 pi over 4. And 8 minus 3 is 5. So my negative angle would be 5 pi over 4.
The negative angles.
No. Okay, so let's do one more. So I have my circle. Okay, and I know that pi over 3 cuts this into thirds, right? So we know that pi over 3 is somewhere up here. Okay, where this is one of my third sections. So if I'm going negative 2 pi over 3, then I'm going to go back 1 pi and then back 2 pi. So I know that negative 2 pi over 3 is somewhere down there. Okay, so that's this whole section. Because I went backwards. Okay. So then to find my positive angle, I have to go in the positive direction. So if I go in the positive direction down to where I get to my angle, I know that this whole top half is what? Pi. Yep, the whole top half is pi. And then I went even further down by pi over 3. So I know that my first angle is pi plus pi over 3, which is the same thing as 4 pi over 3. So my positive angle is 4 pi over 3.
Why 4 pi?
Because pi is the same thing as 3 pi over 3. You have to get common denominators to add fractions. And 3 plus 1 is 4.
Why is that?
Because that's my angle measure, because I had to go backwards, because it was negative. So that's my angle measure. So then to find my negative part of my angle, I go backwards. So my negative angle remains the same at negative 2 pi over 3. So a lot of times your angles will remain the same. Okay. So the other part of what we're looking at today is going to be complementary angles and supplementary angles, which are different than coterminal angles. So a complementary angle is when your two angles add up to pi over 2. A supplementary angle is where your two angles add up to pi. Okay, so just like in geometry, if something was complementary, then it added up to 90 degrees. This one's going to add up to pi over 2, which is the same thing as 90 degrees. And then your supplementary is added up to 180, which is the same thing as adding up to pi. Okay. So we're going to find the complement and supplement of 2 pi over 5. Okay, so if I start with 2 pi over 5, I know I'm going to need to add some angle to that to make it be pi over 2, and that's going to be my complementary angle. Okay, well the first thing I have to get is common denominators. So I know that I'm going to need to multiply this by 2 and multiply this by 5. And whatever I do to the bottom, I have to do to the top. And this one is going to be like 10b over 10. Okay, well 5 times 2 is 10. Pi over 2 times 5 is 10. Oh, I'm supposed to be multiplying by 2. Sorry, that's why that ended up being screwed up. So 4 pi over 10. There we go. That makes more sense. 4 pi over 10 plus some angle b, which equals 5 pi over 10. Okay, then once I know that, then I can subtract 4 pi over 10 to solve for b. So 5 minus 4 is 1, so I just get pi over 10. So my complement is going to be pi over 10. To find my supplement, I take that 2 pi over 5 again, and I'm adding an angle to that, but this time I want to make it equal pi. So to get common denominators, I'm going to multiply by 5. So then I have common denominators of 5. So I end up with 2 pi over 5 plus b equals 5 pi over 5. Once I have common denominators, then I can subtract my 2 pi over 5 to solve for b. subtract 2 pi over 5 to solve for b. So b is equal to 5 minus 2 is 3, so b equals 3 pi over 5. Okay, we'll do the same. I can go back. Can I go back? There you go.
All right.
Yep. Okay. Okay, if we do the same thing for complement and supplement of 4 pi over 5, I know that I'm going to need to get 4 pi over 5 plus some angle measure to equal pi over 2 for my complement. Okay, and to add or do anything with fractions, we have to have common denominators. So times 5 times 5 times 2 times 2. I'm going to get common denominators of 10. So 2 times 4 is 8, so 8 pi over 10 plus b equals 5 pi over 10. Okay, so what do I need to do next to solve for b? Perfect, subtract 8 pi over 10, subtract 8 pi over 10. So then what does my angle b actually equal? Perfect, negative 3 pi over 10. Okay, so my complementary angle is negative 3 pi over 10. To find my supplementary angle, I take that 4 pi over 5 again. I'm adding something to that, but this time I want it to equal pi. So I'm going to get common denominators by multiplying by 5. So I end up with 4 pi over 5 plus b equals 5 pi over 5. Okay, so what's my next step? Mark, what's going to be my next step?
Check 4 pi.
Okay, perfect. Subtract 4 pi over 5. Alright, so Kelson, what do I get for my angle? There you go, 1 pi over 5, which is the same thing as pi over 5. Alright, so that's radians. The second part of what we're looking at is degrees, which is also on your unit circle picture, but it's important to know the difference between radians and degrees. And so we should all be fairly familiar with the idea that all the way around our circle is 360 degrees. Okay, so then halfway around our circle is 180 degrees. The other two kind of common degree measurements that we need to know is the 30 degrees, which is the same thing as pi over 6, and your 45 degrees, which is the same thing as pi over 4. Your angle theta is still measured the same way. Where you start on your x-axis, you move counterclockwise until you get to your terminal side. You're still going to measure degrees the same way. So then our complementary angles and our supplementary angles, this stems from your geometry, is similar to what we're doing with our radians, except in this case we're looking at degree measure. So your complementary angles add up to 90 degrees, and your supplementary angles will add up to 180 degrees. Okay, and then some people find it easier to work with one over the other. So there is a way to convert from radians to degrees or degrees to radians. because it depends on whether or not you prefer to use radians or you prefer to use degrees. So to go from degrees to radians, you multiply by pi over 180 degrees. Okay, so you multiply whatever you're doing by pi over 180. If you're going the other way and you want to go from radians to degrees, then you multiply by 180 over pi. Alright, so we're going to take 135 degrees and we're going to convert it to radians. So we said to go from degrees to radians, that we multiply by pi over 180 degrees. Okay, so I'm going to take 135 and I'm going to multiply by pi over 180. And this is the same thing as 135 over 1. So I end up with 135 pi over 180, which then I can just start reducing. I think it reduces by 5. So I end up with 27 pi over, I don't know what 180 divided by 5 is. Over 36, which then I reduce by 3. So I end up with 9 pi over, oh, I can reduce this by 9. Well, anyways, if you reduce it all the way, then you end up with 3 pi over 4. Okay, so you'll take what you get and then you reduce it. Okay, so multiply by pi over 180. Or to take something from radians to degrees, then we multiply by 180 over pi. Okay, so if I take negative pi over 2 and I multiply it by 180 over pi, then I know that my pi's cancel. So I end up with negative 180 over 2, which then reduces down to negative 90. So you'd end up with negative 90 degrees. Okay. All right. I'm going to give you guys your assignment, but we're not going to start it till tomorrow. Okay, so you guys are going to start page 2, or we're going to start tomorrow, 288, 17 through 28, 31 through 34, 45 through 50, 53 through 56.